Hey everyone, you know that feeling when you're just staring at a wall of numbers on a spreadsheet and your eyes just glaze over? Well, today we're going to change all that. We're about to crack open the Data Detective's toolkit, and I'm going to show you how to find the amazing stories that are hiding in plain sight. Let's dive in.
So think about it. Every single data set, every collection of numbers, it's really asking a question. It's whispering a secret. But that answer? It's usually locked up tight. And that's where we come in. As data detectives, it's our job to find the key, to pick that lock, and to pull back the curtain on the story that's been waiting inside all along.
All right, here's our first case file. Just a handful of numbers. Right now, this is just noise, right? It's a jumbled mess of clues thrown on our desk. I mean, what does this even tell us? Absolutely nothing yet. To make any sense of this, we're going to need to pull out the right tools from our kit. In that amazing toolkit, it's called Descriptive Statistics, and I want you to literally picture it as a detective's kit for data. We've got our magnifying glass to get a closer look, a fingerprint kit to spot the important patterns, and a big old evidence board to pin all our clues together and see the bigger picture.
Okay, first things first. In any investigation, what's the number one rule? You got to find the center of the action. Where do things usually happen? We need to figure out where our data points tend to hang out, to find our usual suspect, that one value that kind of represents the whole crew.
And when we're looking for that center, we've got three main ways to go about it. Think of them as our top three suspects. First up, you've got the mean. That's just the good old average. Then there's the median, which is the number that's literally in the middle of the pack if you line them all up. And finally, the mode, which is the number that shows up most often.
So let's run the numbers on our little case file. The mean, or the average, comes out to 53.9. The median, the guy in the middle, is 53.5. But the mode? Ha! Well, would you look at that? We don't have one. Not a single number repeats. And that, right there, is our first wheel clue. It tells us there isn't one popular value that everyone is clustering around.
Okay, so we have the mean and the median, and they're pretty close, but which one should we really trust? Well, here's the deal. The mean, it's a bit sensitive. A single really high or really low number, what we call an outlier, can totally throw it off. It's like a seesaw with a huge weight on one end. But the median? Oh, the median is solid. It's not bothered by those crazy extreme values at all. So when you've got some wild data, the median is definitely your go-to detective.
All right, so we've nailed down the center of our data. That's a huge step, but it's only half the story. Now we need to zoom out and survey the whole scene. Are all our data points clustered tightly together, or are they spread out all over the place? We need to get a sense of the chaos, if you will.
And that's where measures of dispersion come in. These tools help us understand exactly that, the layout of the scene. Is everything neat and tidy with all the clues in one place, or is it a total mess with stuff scattered everywhere? A small spread is a tidy case. A large spread, well, that's when things get interesting.
So let's start with a couple of simple tools. First, you've got the range. Super easy. It's just the distance from the smallest number to the biggest one. For our data, that's 18. Then there's something called the interquartile range, or IQR. This one's a little smarter. It focuses on the middle 50% of our data, telling us how spread out that core group is. In our case, it's 9. This is awesome because it helps us ignore any weirdness happening at the extreme ends.
Okay, the range and the IQR are useful, for sure. They give us a good first look, but they don't tell us the whole story, do they? What I really want to know is, on average, how far away is any typical data point from that center we found? What's the average distance from the mean?
And to answer that question, we bring out the big gun, the standard deviation. Now, I know, it sounds super complicated and scary, but I promise the idea behind it is actually pretty straightforward. Here's how it works. First, you find the mean, just like we did before. Then, for every single number, you figure out how far away it is from that mean. Next, and this is the clever part, you square all those distances to get rid of any negative signs, and then you find the average of those squared distances. That number has a name, it's the variance. And for the final step, you just take the square root of that variance and bam, you've got the standard deviation.
So, after all that, what's the standard deviation for our little data set? It's 5.88. And what does that number actually mean? It means that a typical or standard data point in our set is about 5.88 units away from our average of 53.9. It's one single number that gives us a really powerful sense of how spread out everything is. Pretty cool, right? Okay, let's recap. We've found the center, we've measured the spread, so what's left?
Well, it's time for the final phase of our investigation, profiling the data. We need to understand its character, its personality. What's the overall shape of this distribution?
And for that, we have a tool called skewness. The best way to think about it is, we're checking to see if our data has a limp. Is it perfectly balanced and symmetrical, or is it kind of lopsided, leaning more to one side? Skewness tells us if there's a bias, a pull in one direction, and that can be a super important clue.
So there are basically three profiles we're looking for. If the mean and median are hanging out together really close, then our data is symmetric. It's balanced. But if you have some really high values pulling that sensitive mean upwards, making it greater than the median, we call that right-skewed. And if the mean gets dragged down by low values, making it less than the median, you guessed it, that's left-skewed. See? It all comes back to the relationship between our two key measures of sensitivity.
So let's bring it back to our case. Remember our numbers? The mean was 53.9 and the median was 53.5. I mean, they're practically the same. What does that tell us? It tells us our data's profile is really symmetrical. It's walking a straight line, no limp in sight. It's not getting pulled one way or the other.
All right, detectives, this is it. The moment we've been working towards. We've found the center, we've measured the spread, we've profiled the character. It's time to lay all our evidence out on the table, put all the clues together, and finally solve this case.
So here it is, the official case summary. The central tendency, our usual suspect, is right around 53.9. The typical spread, our standard deviation, is about 5.88. The middle 50% of the action is happening within a 9-point spread, and the entire scene spans a range of 18. And the character profile? We're looking at a pretty symmetrical distribution. The case of the jumbled numbers is cracked.
But wait, what if I told you we could take all of that information, the center, the spread, everything, and put it into one single powerful picture, an image that tells the entire story in just one glance? Well, we can. This right here is a box plot, and it's one of the most brilliant tools in a data detective's kit. Look at this. That box in the middle, that's our interquartile range, the middle 50% of our data. That line cutting through the box, that's on median, the true center. And those lines sticking out, the whiskers, they show us the entire range, from the lowest value to the highest. It's the whole story, right there in one elegant picture.
And that right there is the whole point. That's the real magic of descriptive statistics. It's not about doing math for the sake of it. It's about taking what looks like a sea of random, chaotic data and turning it into a single, simple, understandable story.
So there you have it. You now have the basic toolkit. You know how to find the center, how to measure the spread, and how to profile the shape of any data that comes your way. So the next time you're faced with a bunch of numbers, don't back down. Look at it, lean in, and ask yourself, what story are you trying to tell me? Because now you have the tools to find out.